Hello. What I'm going to do in this section is walk through permutations with repetitions. So that'd be like repeated values and how they affect the number of combinations that we could possibly have. And then circular permutations, which would be like if I had a bunch of people standing in a line and I wanted to order them, I could do it so many different ways with a permutation formula. But if I took those same people and sat them around a table, I'd really be looking at how many different unique ways could I order them so they'd be sitting next to different people. So there's a couple formulas that we'll go through with these, and we're going to start off with the permutations with repetitions. So first of all, I have 5 letters here, and what we do is we notice that I have 2 of the same letter. So if these are 5 different letters, I would be able to just do 5 factorial, which is 120, and then we'd be all cool, and there would be 120 different ways I can combine them. However, because these 2 letters are the same, it's going to make a couple of the different combinations be the same thing. So let me kind of just give the example of that. If I wrote B, and then I'm going to take my first O at the top, and I'm going to put that one in blue. And then I'll do, let's say I have an L, an E, and then I make my other O the letter, or the color green. If I have these 5 letters, that would be different from if I had like BL, and then I put this O here, and then let's say I put the E here, and then I put the other O here. So I could flip-flop those 2 spots, and it does make a different combination. However, if I were to take that first one that I write and simply flip-flop my 2 colored O's, what you would notice is these 2 now are going to match. The first one and the third one are the same thing. Even though the 2 O's did flip, it makes the same combination. So what happens is there's all these different ways that I could arrange these letters. Again, there's 120 different combinations of them, but because these repeats in here, we got to get rid of them. So there's a formula I'm going to drop on you. And here's another example of how we would do this. But the formula says that the number of permutations of n objects, so we just had 5 objects, which are P alike or Q alike. So in our case, we had 2 of the letter O's. So what I would do is substitute 2 factorial into my denominator then, so you don't need to have multiples. The P and the Q would be if I had 2 different letters that repeated. But all that really matters is that you realize that the N is how many total letters I have, and then your repeats would come down below. So I could go back to that same example, and I could just make 5 other different letters. Let's say I have A, B, C, and C. What we would notice then is I still have 5 different letters. However, I have 2 of the A's, and I also have 2 of the C's. So you could evaluate this by, again, 5 factorial is 120, 2 factorial is 2 factorial is 2, and the other 2 factorial is 2. So what I would really have is this, and that is going to really narrow down the number of possible combinations that I have, or permutations really. So we're going to do another example of applying that formula. So how many 8-letter patterns can be formed from the letters of the word parabola? So first thing, they're already telling us right here that we have 8 letters. So if I want to figure out the number of permutations of this, and going back to my formula here, again, I'm taking n factorial over, in this case, the only letter that repeats is my letter A. Everything else is unique. So what I would do then is I would just have that one value at my denominator. So I take my 8 letters, so 8 factorial, divided by how many times that letter repeats. So we notice that we have 3 of the letter A, so I would put 3 factorial down here. And you could either simplify this in your calculator, which I'll walk through that calculation. Again, what I would do is take 8, I can go to math, go over to probability, the 4th option is the factorial, and I want to take that value and divide it by my 3 factorial. Oops. So, here we go. So 3 factorial, and that's going to give me 6,720 different combinations, or really permutations, that I could have of those 8 letters. So we notice what actually happens. If I did the 8 factorial first, again, assuming, let's just say I picked A, B, C, D, E, F. Oh, let me just write this out. 1, 2, 3, 4, 5, 6, 7, 8. Let's say I picked these different letters. I want to know how many different ways I could arrange that. That would just be 8 factorial, which again, that's this huge number of 40,320. However, because I have the repeated a value, it really narrows it down and makes almost like 1/4 or 1/5 the amount of values that I actually have. So we'll do another example where we have multiple letters that are repeating. First of all, MISSI, SSIPPI, good old Mississippi. I have 11 letters here. So I know that my numerator is going to be 11 factorial, and now I'm going to end up looking at how many of my letters repeat. So I notice that I have an I here, an I here, 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 and here. So I have 4 of my I's, so that's going to be 4 factorial. I have 1, 2, 3, 4 S's, so that's a 4 factorial. And then I also have 2 of my P's. So that's going to be 2 factorial. So again, you can go to the calculator. Keep in mind you would want to keep that denominator in parentheses then. So if you threw that in your calculator, you would end up with 34,650 11-letter patterns. All right. So then we go on to these circular patterns. So if I just had 6 people in a line and I want to know how many different ways I could order them, it's the same logic. I really have 6 factorial different ways that I could order 6 people. So that's really 6 times 5 because it's saying, hey, I have 6 options for my first person, 6 for the or 5 for the second, 4 for the third, 3 for the second, and then 2 and then 1. However, if I have something like this, so if I took my 6 people, and another different order would be like if I put 3 next to 5, and then I had 1 here, and I had 6 here, and then 2, and then 4. That's a different arrangement of people. And I could do the same thing, another example of this. However, what if I took my people 1 through 6, and all I did was just shift them down 1? So I moved every person down 1 seat. Well, the thing is, they're all still sitting next to the same people. We notice that this could even occur 2 more times. Person 1 could be sitting where person 2 is. Person 1 could also be sitting where person 3 is. And I could keep rotating this. So notice that that's going to happen 6 times. So what ends up happening is we have a formula for this that says I'm still going to take my 6 factorial for my numerator, and that's what told me my number of possibilities in general, but you just have to divide it by the number of people that there are. In this case, there were 6 spots, so 6 would go on my denominator. So what ends up really happening is you have n factorial over n, which if you were to write this whole thing out, again, I could kind of give you an example of this. Let's say we wrote out 4 people. If I had 4 times 3 times 2 times 1 over 4, what we notice is what's really going to happen is it's going to take away one of my multiples here. So another way that we really simplify this then, because you would notice like the 6 repeats here, or the 4 repeats here. Another way that you can write this formula is just taking n minus 1 factorial. So instead of writing this whole thing out or using this formula right here, I would use this guy. I would take the number of people that there are, subtract 1, take a factorial. So let me do another example of this. By the way, here's the 2 formulas that I just went over. So let's just say I had 8 different people around a table, so I'll use kind of the same example. If I had 1, 2, 3, 4, 5, 6, 7, 8, notice who's sitting next to who. Again, the reason for this formula is because I could just shift every person down and say I have 1, 2, 3, 4, 5, 6, 7, and then 8, and you have the same people sitting next to each other. So these technically represent the same formation. If I ordered these numbers in a line though, let's say I had 1, 2, 3, 4, 5, 6, 7, 8, and I switched my order by bumping everybody down 1, so 8 came to the front, I would have 8, 1, 2, 3, 4, 5, 6, 7. These 2 8-value strands of numbers are different. So the circle is what really changes it. So if this were my case, again, I would just take my number of people minus 1 and throw a factorial on there. So if you put 7 factorial into your calculator, it would tell you how many of these rotations there would be. So let's see one more example. At a family-friendly restaurant, 9 bowls of food are placed on a circular revolving tray in the center. You can serve yourself from each of the bowls. So imagine you have this big circle in the middle with 1, 2, 3, 4, 5, 6, 7, 8, 9 different little bowls inside, and they're just going to keep spinning around here. So is the arrangement on the tray linear or circular? Well, duh, it says that it is a circular revolving tray. So this is going to be a circular permutation, which again, you're basically saying how many different ways could you arrange those 9 different bowls without simply spinning the tray and calling that a different rotation. So how many ways? Again, you have 9 bowls. You just take away the 1, throw a factorial on there. So 8 factorial is going to come out to 40,320 different arrangements, which again, that would be like if you just picked 9 total bowls, threw them on a tray. If you rotated that entire tray one time, it's still the same order of bowls. So that's why we're doing this formula in the first place, is because of those repetitions, which would occur 9 times then for each one of those orders. So by just taking away the 1 and throwing a factorial on there, we have our answer. So quick recap then, that was the circular stuff. Before that, we went through what we did with repeated values in there. And again, just eliminating the number of repeated combinations in each of those cases.